Hello everyone, I'm Feng, and today I will share the topic of MPG, the multi-project glass substrate solution. I come from Tianma Microelectronics company. This is a state-owned holding company established in 1983, specializing in development, manufacturing, and sales of small and medium-sized display modules. It was listed on the Shenzhen Stock Exchange in 1995. The current asset scale is $11.3 billion, and annual sales exceeded $4.6 billion, with multiple branches around the world. In addition to the Asia-Pacific region, there are also branches in Germany, the United States, and India to serve global customers. I'm responsible for Smart Sensor Department and the Innovation Center in Tianma. The report is divided into 4 parts: MPG Background, Introduction, Technical Description, Process Description, and Summary. First, the introduction of the background part of MPG. The development and large-scale application of new technology such as 5G, big data, cloud computing, and AI. The IoT has shown a vigorous development trend. According to the statistics of Market Survey Agency in 2020, the market size of IoT exceeded $761 billion. The market scale of the smart sensor has also reached $36.6 billion, which acts as an interface of IoT. And the number of IoT interface ports will also reach the trillion level in recent years, and it is increasing year by year. On the other hand, the development of a traditional sensor technology has also encountered various challenges, such as the diversification of sensor function requirements, including physical signals such as pressure, strain, and magnetism, and chemical signals such as gas, ions, and biochemistry, such as a large area array, flexible configurations, multi-sensor integration, and other personalized requirements. Another example is the design verification of new sensor material and new architectures, including elastomers, piezoelectrics, photosensitive material, new semiconductors, nanostructural functional materials, and so on. At the same time, most of the current sensors are based on silicon wafer technology, which is limited in production capacity. Therefore, the current mainstream silicon wafer fab factories can't support the low-cost development of such emerging sensor technology and large-scale production. How to effectively transform, diversify the new technology research into products has become a huge challenge. The Multi-Project-Wafer plan named MPW has partly solved the development difficulties. The specific approach is that multiple projects share the same wafer, produce experiment samples with different functions, and uses under basically the same process conditions. This approach minimizes the development cost and shortens development time. However, there are still limitations such as long production cycle, high cost, and few product samples. A new solution that I want to introduce to you today is the multi-project glass substrate concept called MPG. Specifically, multi-technology solutions are placed on the same TFT substrate mask. Simple adjustments and combination are based on the similar process flow, and then output the engineering samples and deliver them to customers. This mode has some features that MPW doesn't have. For example, easily make a large area, because the production capacity is sufficient and output can be large. The resolution accuracy can reach the micron level. The cost will be low, and the substrate can be transparent and flexible. Some simple circuits can be integrated on the glass substrate. By using the mature TFT LCD module production line, the module process is easy to deal. We can provide more services than design verification, such as the inline verification of new materials and new equipment. But at the same time, the MPG projects also have some challenges. For example, the area of the mask is large. The demand for samples is usually a small area. Therefore, multiple projects from different customers are required to be fully filled. With the addition of the need to integrate the request of different customers, it will consume more R&D resource. For another example, the current existing process and equipment are configured for the manufacturing characteristic of the display panel, corresponding to the development request of different sensor technology. Investment and adjustment is required. Because of the lack of a standard process and device model, it requires multiple communications and exchange between the MPG Foundry and the customers in deciding the schemes. In some cases, may make some mistakes in some details. Another point is that the current production line is a mass production line, and there will be uncertainties for the coordination of production capacity. Next, I introduce some technical details related to MPG. For MPG, we prefer to select a small generation line which is more flexible. There are some reasons. Firstly, some lines have relatively high accuracy. Secondly, it can flexible provide various of substrate technology, such as amorphous silicon, LTPS, and Oxide. Thirdly, it is easier to change the line and process recipe. Fourthly, the equipment modification and investment costs are lower. Small line can meet the need of a small number of diverse customizations. MPG program can provide a variety of options. For the substrate, N-type or P-type TFT can be provided. Different metal layers, insulating layers, organic layers, and other functional material can be made. At the same time, part of the circuit can be integrated. Can provide a flexible substrate such as a laser lift-off type per image, ultra-thin glass below 0.15 mm, and so on. For more lower resistance requirements, thicker copper wire can be plated on the glass. The optical film layer can be made in different ways. It is also possible to drill holes on the glass substrate by laser or CNC and realize two-sided conduction through metal interconnection. At the same time, thanks to the effort of material manufacturers, more functional materials have been developed. For example, low-loss substrate glass suitable for high-frequency signal transmission, organic material with low dielectric constant, and so on. Based on the current mainstream TFT mass production process line, the key process equipment of the MPG program can be used, which include PVD, PECVD, photolithography, wet dry etching, stripe ELA doping, coating, printing, and so on. According to different target material, different metal layer material can be made with a thickness of a nanometer to micron, and the line width can be reached 2.5 micron. CVD process can produce different semiconductor layers and insulating layers with different gas, and can produce different organic material layers through coating and printing process. The basic process flow of mass production TFT is similar to that of a silicon wafer. A process cycle includes clean, deposition, PR coating, exposure, development, etching, striping, inspection, and after multiple cycles can get the device structure that we want. A typical manufacturing process of LCD array substrate is divided into 5 steps. Gate method represented by number 1. Number 2 represents the active layer. Number 3 represents the source and drain layer. And the through hole represented by number 4. The pixel electrode represented by reference number 5. How does the MPG project work? Taking Tianma as an example. Here is a simple diagram. First, the customer established a connection with the RD team of the MPG Foundry, signs relevant agreements, and provide the request information for some special type of designs or more diverse categories such as TEG. And the foundry factory usually interests a designated company to integrate the corresponding design content. Then introduce the MPG process descriptions. Take Tianma as an example. Under normal circumstances, after receiving the customer's needs, evaluation and project approval will be carried out. The kickoff will be set up after the commercial agreements are signed. Generally speaking, it takes 3 to 7 months from kickoff to sample output. This time depends on sample complexity and production line capacity deployment. This process goes through 3 main procedures: design, manufacture, and test. The design process integrates requirements, determines the process flow, confirms and optimizes the mask design plan. The production process generally selects mature and stable process conditions to ensure the quality of the output. The testing process will test control parameters to ensure that the sample meet expectations. Multiple projects were placed on one set mask. Usually, the total area of the mask is certain. Design the mask according to the size required by each customer to maximize the use of effective area. Depends on the exposure recipe. 2 or 4 samples can be produced on a single substrate. After cutting, a separate glass sample can be produced for glass input to finished product output. The TFT production line uses a fully automatic equipment. The process flow of the sample is controlled by only by recipe, taking into account the technology incubation effect and the social effect. About the MPG cost, Tianma currently adopts the lowest fee mode. According to the complexity of the design, the material and the production cost are estimated. It is hoped that the incubated technology can promote mass production with customers and achieve a win-win situation in the future. We cooperated with the Institute of Microelectronics of the Chinese Academy of Science to develop process design kits based on production line technology named PDK. PDK for amorphous silicon is available now. With the PDK, we can convert a model to layout by inputting key parameters. It is also very easy to run DRC, LVS, and parasitic parameters extraction. Multiple projects were placed on one set mask. Usually, the total area of the mask is certain. Design the mask according to the size required by each customer to maximize the use of effective area. Depends on the exposure recipe. 2 or 4 samples can be produced on a single substrate. After cutting, a separate glass sample can be produced for glass input to finished product output. The TFT production line uses. Tianma has opened 3 generation 4.5 lines this year for MPG, which is located in Chengdu, Wuhan, and Shanghai. The Hubei New Display Innovation Center will be opened in the second half of 2021. I will elaborate on the Innovation Center next. Hubei Changjiang New Display Innovation Center mainly served as the entire industry, mainly used for the development of new technology, new material, new equipment, and new processes, determined to become an innovation R&D line for new TFT substrate, new display devices, and related supporting technologies. The total investment of this innovation platform is $23 million. We are determined to provide a full range of technical services for industry chain partners and customers, universities and research institutions, as well as technology-based startups. The technical categories supported by each production line of Tianma will have their own emphasis. The G.5 mass production line focuses on mass production mature process flow, such as amorphous silicon, Oxide. Innovation Center focuses on new technology such as LTPO and flexible substrate. Tianma will select the appropriate process flow and production line according to the customer's needs. The MPG project has been tested in Tianma and has got some good results. Here is a brief demonstration. The first one on the left is the photosensor, which cooperates with the Peking University, and the current feedback has initially achieved the expected result. The middle one is a large-scale array digital microfluidic developed in cooperation with the Linkzell and SL company. The samples have reached expectations, and the paper based on this will be published on IEEE 2020. The middle right is a array-type tactile sensor, joint completed with Sun Yat-sen University and the Chipway company. It is also achieved the basic function. The one on the right is a large area transparent fingerprint sensor, which I dependently developed by Tianma, which realized the two-finger recognition function of the transparent substrate. This year, Tianma launched the second round of MPG program. The substrate technology used this time is Oxide. Peking University, Tsinghua University, Shanghai Jiaotong University, Sun Yat-sen University, and Shenzhen Institute of Advanced Technology Chinese Academy of Science, Chipway, and Linkzell have already participated, and the progress is now smoothly going on. Finally, let's summarize. Tianma relies on its flexible and diverse manufacturing capacities. It can provide MPG service for enterprise, universities, research institutes, and other institutions. MPG has been successfully implemented, supporting the R&D activity of many universities and startups, and accelerating the pace of technology to product. Hoping that through this platform, we can provide more convenience for everyone, accelerate the development and interaction of low-cost, large-scale sensor technology, and create value together. Finally, I got the help of many professors and friends during the formation of the MPG plan. Allow me to thank them for their support. In particular, Professor Guo Xiaojun from Shanghai Jiaotong University has conducted many in-depth discussions and practice with us from formation of the concept of MPG to the final implementation. It can be said that this platform may not be final formed without the efforts of Professor Guo. At the same time, during the implementation of 2 rounds of the MPG plan, Dr. Hanbin Ma from Excel, Mr. Xinghui Liu from Chipway, Dr. Lin Runfeng from Linkzell, Professor Shen Dongzhang from Peking University, Professor Chunlei Yang from Shenzhen Research Institute, and Professor Kai Wan from Sun Yat-sen University, Professor Xueqing Li of Tsinghua University, as well as strong support of related teachers and friends. Thank you, everyone. The above is all the content reported today. Thank you all for listening. The bottom right corner is the contact information of our technical window. If you are interested in MPG, welcome everyone to contact us. Thank you all.